This is a compilation of the most advanced healthcare, fire, HL7 regulatory compliance dealing with CCPA, GDPR, HIPAA, and most scalable and quick data migration to and from RDBMS and big data with end-to-end encryption of all data. This is brought to you by BDR, and you'll be amazed at some of the technologies, if not all, that you will see right now. Even though fire is healthcare's future, they're still years away for most. BDR is now delivering an innovative HL7 that has encryption, mandated patient downloads, migration to big data, interoperability, and analytics with end-to-end encryption. It's really now BDR has become the HL7 JSONized nucleus to meet regulatory requirements that have been overlooked in FIRE's unanticipated complex rollout. We also strongly recommend against tokenization and masking versus encryption, such as AES-256, for you might have failures within FIRE's linkage and blog architecture that utilizes those to have joinability of the data. Here we are now starting the demo. We're going to show in HDFS that we have raw HL7 information that would come straight from a hospital or any healthcare facility. We're now going to go run a job to convert the raw HL7 into a JSONized HL7 so it's then usable for reporting for migration to big data. We're going to migrate it to Snowflake first. We're going to go into an existing Snowflake data warehouse. We're going to give it a table name, and then we're going to take the raw JSON, I should say the raw HL7, and we are going to JSONize it and store it encrypted inside of Snowflake. We can do most every big data that's out there, or even back to other RDBMSs. So here now we refresh Snowflake, and we can see we have the new table, and in that table the raw HL7 is now in a JSON format, fully secured and encrypted. We're going to go through this same exercise and read HDFS. We could read server directories. We can read it from S3 and other sources. We're going to read the HDFS, and this time write it back to HDFS, which you can put into encrypted zones for additional security, though we are going to be writing it encrypted ourselves. So now we're going to create a new folder within HDFS called JSON. We're going to run the process, and we're going to take the raw HL7, JSONize it, encrypt it. It'll all be converted and ready for use for patient downloads or for data scientists or other analysts to work with the data for analytics purposes and for very quick retrieval and interoperability with other doctors and facilities. And we see that the new JSON is encrypted sitting here in HDFS. Now what we want to show is how to generate reports for patients to meet the July 1st ONC mandate. So now we're going to go take one of the converted JSON files, and we're going to take the message types, and then we combine these segments and columns. We're going to allow the patient, the user, the analyst, the data scientist to select the information they want. If there are a lot of them, they'll be able to do selection criteria with probabilistic matching, find the segments and columns or the message types that they want to report on. They're going to run the report, and they're going to get a generated report back to the BDR graphical interface. Here we can write the data back to other databases and data lakes, or we can download it to the specific device that they're on or that they choose. We're also showing that even in the report we can do search criteria. So now we're going to download the report information, and we use multi-factor verification and authentication. In this case we're using Google two-factor open source. So we're going to go to, it changes every 30 seconds. So we waited for a new key. We put that authentication key in within the 30 seconds. We then generate an encryption master key, which will be different for every download for security purposes. To get one key, it won't work again for the next download. And here we can see we've downloaded end-to-end encryption and to a CSV file. We want to show here that we have bubble help because there are so many different EMR types and all different types of healthcare formats and naming, so we want you to be able to put your own names in so you understand the data much better. Now we're going to go in and we're going to show I'm on an iPhone. I connect to the IP address, which would be secured to the Big Data Revealed application. I'm viewing the report here from an iPhone. I don't need an additional iPhone app. I do need two-factor authentication. Here I'm waiting for a new key. I'll enter that key. I'll then accept the master AES 256 encryption key, and the file will be downloaded to the iPhone using HTTPS, SSL, SSH, and other security. And then there's the generated report. I can look at it different ways. I can view it, I can share it, download it, and securely allowing us to meet the regulatory requirements. So I hope this video shows that we've taken care of the needs that are necessary to meet compliancy and regulatory compliancy for HHS, HIPAA, ONC, CCPA, GDPR, to protect PHI and PII. And in our next video, like always, we'll show more innovations and abilities. Thank you. In this prior video, we have added PostgreSQL 12 and MongoDB as targets to our big data offerings, and we'll be adding more to this shortly, but we have now covered most every major big data repositories with JSONized HL7 data. BDR migrates any HL7 data directly into big data repositories. This becomes really useful to get by the second, by the minute results that are important to patients as much as it's important to marketing people. Use our graphical interface, which I'm going to show you now for big data repositories, and we're hoping soon at the end of the month or a few extra weeks to be able to migrate all this HL7 JSON format that we're converting raw HL7 into JSON, and then get that into Fire JSON into Fire servers. Our processes will be scalable, low latency, accurate set of microservices that will reduce months, if not longer, of efforts to just minutes and hours. So we are going to go take a look at this now. Now let's move on with the demo. So first, what I want to show is the file system. So in the file system here, we're going to look at we're going to be taking in HL7 raw data. That could be put into a C directory, a server directory. Now let's move on to the demo. Here what I want to show is we're going to be working with raw HL7 data that was taken into HDFS. It could be taken into a C drive, file directories, S3, several other locations to then be processed. So here we're going to look real quick just to verify what's in this data. So here we can see, as we open up this data, we have decrypted raw HL7 messages and transactions. So what we're going to first do is we're going to go into the HL7 processing jobs. We're going to convert the jobs into an HL7 JSON and then move it to one of several locations. The locations that we will have available by the end of the week are going to be, well, and you'll see a lot of them today, is Snowflake, S3, Redshift, Postgre, MongoDB, and others. So first thing I'm going to do here is I'm going to say, okay, I'm going to take in HL7 raw data from HDFS, and here we have the HDFS data we selected. We're going to write this to Snowflake. We're going to use an existing warehouse that we already configured, and we have these pre-configured in the administration. So I will take today's date, 10/13, so we'll do HL7 10/13 is our Snowflake output table. We'll test our connection. Our connection's fine. We're not going to save that, and we're going to run our process. So right now we are taking that information. So we are going to go over into our connection in Snowflake, and we'll refresh and wait. As we can see, we've run other user runs earlier, and I can even just preview some of that data to show you. Same example I ran earlier, but we're running a fresh one. And as you can see, it's now in a JSON format, and the data is encrypted. Everything we do is end-to-end encryption. We can even encrypt the HDFS input raw data or whatever directory it's in, and that's something that we suggest that should be done. So let's refresh again. So now here we see HL7 Snowflake with the date that I picked, and we will open up, preview that data, and as we can see, just like the others, we now have it in a JSON format, and it is securely encrypted. Now let's go in and run another process. So here we're gonna convert, and I just want to show it first. So let's go look at the S3 directory, which we can do from the Big Data Revealed app. And if we go look at the file content, we're going against the AWS server now versus the virtual machine, and we can see that we have raw HL7 data. Now HL7 process, and we're going to go run and convert, but this time we're going to source the S3 HL7 data. And we're going to select that, and we're going to write that to Snowflake also, and we'll go into the existing warehouse, and here we'll call this HL7 S3 to Snowflake 5, and we'll test our Snowflake connection. It's fine. We're not going to save our passwords, and we're going to run this process. So now we're going to come back over and patiently wait. That's not too patient of me. I'm already refreshing, but we're going to wait until we see that we took the S3 and wrote the S3 information, HL7 segments transactions, and here we have them, and they're encrypted and they're in Snowflake. So there again, we took the S3 input, which could also be an output. So again, there it is in a JSON format, and there it is in its encrypted format. So what we're offering is a much quicker means to be able to take HL7 raw data from server directories, HDFS, where most anywhere they're going to be stored, put them into a JSON format, and then write them to S3, Redshift, PostgreSQL, which we also have a BDR, PostgreSQL warehouse. You can be able to write it to Snowflake, MongoDB, BigQuery, which I'll be showing in a minute. We can, upon request, do SQL Server, Oracle, pretty much anywhere where you can store JSON data, we'll be able to do those conversions. This is the predecessor and the step that's necessary for Big Data Reveal feels we're going to be the first to then be able to work with this data, which we have in the past, but we're working on algorithms and ways and mapping to be able to take this new JSON format of HL7, get it into a FHIR format of HL7, and get it ingested into FHIR, all 37,000, almost 400 columns, and have that automated. So instead of taking weeks, months, or years to get all that mapping done, we're looking to have that automated and have a version of that out within the next month or so. So I thank you for looking at this portion. I am now going to go and turn on the Google BigQuery server and demonstrate us working and writing to BigQuery and Google. So I will be back here shortly. Thank you. Okay, now that we're in the Google Cloud platform, we're looking at the HL7 input of the raw data, and we're going to then write this to BigQuery. So here we're going to go in and do the convert. Here we're looking at only one file in the BigQuery repository. We are now going to take an HDFS FHIR raw HL7 input. We're going to write it into BigQuery. It's all pre-established by the administrator. We're going in and establishing our connection. We're going to give it a name HL7 convert. We're now running the process that's going to take the HDFS raw HL7, write it to BigQuery, and it's also going to JSONize it, and it's going to encrypt that data. Now with the process completed, we will go into BigQuery, we'll refresh it, And we'll see that there'll be a second table inside the schema, and that will be the table that we just created, and that'll be a new JSON version. There it is. So we are going to open up that table, and there we see we have the JSON. We have it encrypted, and it's sitting in BigQuery, and now can be used by analysts. Once again, I thank you for your time to view this demo. And in closing, I just want to mention that soon BDR Fire will deliver primary fire resources fields, extensions, and HL7Z user types directly into Fire servers. BDR Fire already provides secure patient downloads with end-to-end encryption, migration to big data from Fire. Here you saw it from HL7 JSON. Everything will be, again, end-to-end encryption, and the ability to take familiar names from EHR systems, EMR systems that now differ in the Fire terminology, and add metadata so it shows up with the names that you're used to seeing. Again, everything you saw is going to quicken up your ability to deal with hospitals, to deal with patients, to deal with providers, healthcare, pharmacies, and have analysts, data scientists, and people derive very important information to be able to help and aid people in the healthcare industry and for the patients, as well as gather a lot of value information that with consented data to be able to help in your marketing efforts dealing with these results. Again, I thank you. Stay COVID safe and watch for our next video. As we have shown you with other databases for like Google BigQuery, HDFS, S3, Snowflake, and others, we now have created and completed PostgreSQL 12 and MongoDB, so we are going to now show those databases working with the JSONization of raw HL7. So here we can see the data in MongoDB, and we are running our process against the raw HL7, which we're going to select the source, which in this case happens to be in HDFS, which stores HL7 very well and stores JSON very well. But now we're picking MongoDB as a source and giving it a table name, and we are going to take the raw HL7 as we have with the other big data repositories, and we will put it into JSON and make it available to the analysts, data scientists, doctors, and others for their use, and including the marketing people. Now the job should be completing shortly, as it just has. And now we are going to go look at the repository for MongoDB. And here we can see within MongoDB things are now in a JSON format and can be used by data scientists, once again analysts, and others to be able to make business decisions, marketing decisions, healthcare decisions. And now what we're going to do also is to show the PostgreSQL. So now we're showing once again raw HL7 transactions. We're showing a PostgreSQL schema. We're going to go into the process jobs for HL7. We're going to take the same source in HDFS, which are raw HL7 transactions. This time we're picking the BDR warehouse, which just happens to be a warehouse that we created from PostgreSQL 12. We can have a timestamp on the table, and we're going to run this job, and then we'll look at the results in PostgreSQL 12 shortly. Now with the PostgreSQL 12 job completed, we'll refresh the schema. We'll see our new file and file name, and we'll see that we now have the data in a JSON format, which soon we will be offering up this capability to be able to do the queries and reporting straight from our own interfaces. So again, thank you for watching yet another extension of the video as it grows and as we grow the features and functions. Thank you. Here I'm going to demonstrate BDR Fire, which gives the users and you a simple mechanism to find the data that you seek. BDR gives users the ability to add aliases to Fire's column names with all the EHR, EMR, HL7 names to Fire's unique 37,340 column names, which they standardized. So BDR Fire has added the capability for aliases to a cross-reference table for mouse over display when searching for information. So here I'm going to go ask to do a Fire report, and we're going to pick R4, we can do R5, we can do R3, and here I'm going to go for first the patient resource, and here we're going to do a search for a couple columns, but not by the names that are used within Fire, but which are used in other systems that you might be used to. Say you're used to the word town. Well, town is now address and city. Say you're used to first for first name. So if we key in first, we see first name is now given name. If we look for last name, it's now name family. Now if we want to just go to the straight Fire naming convention, then we can go look for other things that we're used to also, and say address, and say we want address country added to it, and then say we wanted to go into another resource, so we can go into the observation resource, and let's say we're just looking for some code information. We can come in here and key in the word code and see that we want code coding display, and now we're going to run this process, and while the report's running, I'll show you from prior reports, you can see what information you went after, what the Fire name was, and what the name was that you searched for, so you'll know that's your value. This process will take the frustration out of people that are used to multiple EHR, EMR, HL7, and other healthcare systems. That's going to take a while to get accustomed to the new national naming and the conventions and naming that fire uses. So till you're fully used to that, or even when you are, you can still go in and search by the names you're used to, because the interface allows you as the user, so while the job is running, we'll go into the administrator process and look at fire configurations as we see in the fire resources. As we go into fire resources and we look at the R4 version, when we come in and we are searching and looking for different fields, like I use town, and town is really address city. The reason it finds that is we allow the user to come in and under a description field, comma delimited, put location, town. It's collaborative, so however many fields people want to put in, they can put in. So you notice I found that with town, so that just simplifies the user's job in finding the fire representation of what you're working with. Now with the job completed, we can click over here to click to view, and we can see the columns that we requested, and we can open up the report, and in the report we can bubble over and see that patient address city, maybe we're not used to that, that's location and town. Patient name given is first name. Patient name family is last name. And if there is no user entered equivalent to a name or conversion, it'll just show none. Now the next thing that we can do is we can report this to a database, or we can download it. So if we were to report this to a database, so you want to do a migration to a big data database in S3 or Redshift, a Snowflake, and HDFS, you can do it. In this case, we're just going to go back to MySQL. We'll call this demo 10 underscore 1 for today. We'll test our connection. We'll hit the next button and the run button, and while this is running, we can go into MySQL, look at the migrate tables. We don't see the demo 10.1 table here yet. We can refresh to see if it got the point to create the schema. Once it creates the schema, it will populate the data, and what's nice is it will populate the data in an encrypted format, which then I'll show you. As long as you have authority, you can decrypt it, or even as we store other data encrypted, as you see here. Fire URLs and APIs will run as usual based on authority. So here we have demo 10.01, which is a new table, and as you can see, it's encrypted. So we securely end-to-end did our processing, and we wrote the file over, and it's an encrypted state. But if we have the authority, we can click the open button, we can click run the process, and the process will run. In this run, and especially because you migrated this, you have ownership of it, but you also have responsibility of that file. Now when we come back, when the process is done and we refresh, it still might be running. but we'll see. And let's right click and select the top 1,000 rows, and now we see that the data is decrypted. And once again, if we wanted to, and we should if we're done working with the data, it's in decrypted format, we would once again want to encrypt that data. Now, when we go look at the display for the report, and before we opened it and we did a migrate to a database. Now, if I am a patient, as of July 1st, I have a right to see my data and work with it. We generate an encrypted key for security using HTTPS, SSL, SSH, and Crypto.js and other security methods without an application, and we could bring this data down to an iPhone, an iPad, most any mobile device or computer. So when I'm done with the process, it's going to start and build a download file and all the security mechanisms. I'm going to save this file, and now I will go into Files, I will go into Downloads, I will look at the last file generated, I will open it in an Excel format, and here we see the data that was in the report, which we have a right to. We can share it with doctors, we can share it with anybody we want, we can just use it for our viewing. Now, since we're still have the data encrypted, which it should be, so let's go into the FHIR repository and let's look at a couple major tables. First, let's look at the string table, and in the string table, which I have open here, we can see, and let me just refresh the data. Here we see that the data, select all, so if we execute that, we can see that the data is encrypted. We'll go to what's called the version table where the blob fields are stored, and we can pick on any one of the blobs, and if we open that up in Editor, we can see that that data is encrypted. Now we're going to go into Postman, and what we're going to be able to do is go into the FHIR data, port 8080, FHIR, patient 1. We're going to hit the send, and you notice that because we're using the FHIR and Hibernate interceptors and our APIs in microservices, we're decrypting the data, making it viewable and available to those that have authority to look at that. If I click on history here, I will see other processes that I ran, and we will look at not just one patient, but we're going to want to look at all the data within that patient. And again, in the bundle and in the JSON format, we can see all the data, all the resources, and everything is in a decrypted format. So what I hope this is showing is that the data at rest will always maintain its integrity of being encrypted from end to end. The blobs that store the majority of the data that's used stays encrypted. Fields that are in the string file that are used with cross-reference files to put together the records for patients is all encrypted. It gets decrypted as needed throughout the processes, but with the interceptors and our APIs and microservices, the data is easy to work with. This is true end-to-end encryption. Our ingestion process encrypts the data, and the data is encrypted and secured all the way down to the iPhone or all the way into its migration into any RDBMS or big data repository that your data scientists and analysts are using. I hope this is helpful to show how we have filled the gaps of areas that weren't and don't meet HIPAA compliancy, CCPA, GDPR, and other compliancies within FHIR, and helps the users protect protected health information and PII for CCPA and GDPR. All the protected data will be AES 256 encrypted. So when you are breached, not if you are breached, your data is secure. And if you back up based on your latency a couple times a day, you can restore it to another cloud, on-prem instance, and be back up and running very quickly and not be threatened by or harmed by a data breach or a ransomware attack. I hope this has been helpful and just shows how much value and how much can be done outside but integrated into FHIR, and how the capability of utilizing like names make the processing within FHIR much easier for people to be able to search and see the data names and metadata that they are used to, so they're not spending 80% of their time just like data scientists were in finding data. Now users won't be spending 80% of their time finding the data. They'll find the data very quickly, know where it is, know what its values are, and be able to work with it. I thank you for taking the time to see this video. We have a complete video library in YouTube, so if you're looking at this one, you can just go to the whole library and probably see 100 or so videos. We do high-speed data migrations, such as to Snowflake from Oracle, as an example, at nearly 2 million rows a second. We do everything dealing with CCPA, GDPR, HIPAA, FHIR, consent. There's just a real lot of areas in data governance, data profiling, outlier discoveries, completeness. This is a really end-to-end technology, and most important, no matter what state you're in, what country you're in, you have a fiduciary legal responsibility from the board of directors to C-levels on down to protect customers' personally identifiable information and protected health information, and we feel we are adding that value for you. Thank you, be COVID safe, and I'll see you on our next video. Thank you very much for joining BDR and seeing how BDR transforms FHIR to meet healthcare regulations and needs. And some of the ways are significant regulatory requirements by CMS and HHS have mandated the use of FHIR for many forms of communication for the healthcare industry. HHS, CMS, HIPAA, CCPA, GDPR, and other regulations should be a substantial concern for C-levels and board members in the healthcare industry and any industry. The key to successfully meeting these requirements is to encrypt all the data in the FHIR database plus all the data in the FHIR blobs, which are in a JSON format. The FHIR blobs are the only complete representation of all the data in FHIR, including information not in FHIR's relational database. BDR will demonstrate how it delivers features missing in FHIR, yet required by regulators and regulations and desired by providers, data scientists, and analysts. This is being brought to you by Big Data Revealed, which we'll refer to as BDR. I am Steve Meister, the architect, designer, and inventor of this technology. Thank you. I will be stepping through this agenda, which will have numerous live videos being taken demonstrating the BDR additional features, graphical interface, and abilities and capabilities that it adds to the FHIR framework, which is added value for the healthcare industry. Now let's look at and discuss the features and capabilities delivered by BDR that make FHIR a more complete product. BDR delivers in days to weeks, literally, the key features needed by the FHIR framework to make your FHIR efforts complete and successful. Traditional designs and architectures of the past will fail when attempting solutions for FHIR. 1. For those providers with Medicare or Medicaid patients, which is about 40 million today and said to go up as high as 90 million in the next 4 to 5 years, you are now obligated by CMS, HHS, to allow these patients to electronically access their healthcare billing and other information and to download this data to their devices, preferably securely. This must be accomplished while you continue to keep the data secure in the FHIR database and data at rest and in motion, and during the transmission of data to the patient's device. That could be an iPhone, an iPad, a computer, a server, most any device with a browser. BDR consultants can show how FHIR data can be accessed by data analysts to overcome FHIR's strikingly difficult restrictions on data extractions, which we will go into more detail later. FHIR was built to deliver one patient's information at a time, or one of FHIR's approximately 150 resources that, if combined, have over 27,000 fields and subfields. The exceptionally difficult structure of FHIR data make it very time-consuming to deliver data for multiple patients and very improbable for ETL, query, reporting, or other tools to create similar extracts for data scientists or analysts. Even FHIR uses intricate, complex, algorithmic processes in order to build a patient's data extracts. Now let's discuss why encryption of data in FHIR servers is the key to avoiding data breaches, ransomware attacks, and other compliance regulatory issues. For successful migration and ingestion of healthcare data into FHIR, the process must encrypt data at the point of the first contact and maintain that encryption until the data is placed into FHIR. End-to-end encryption for data in motion and at rest is crucial in meeting HIPAA, CCPA, CPRA, and GDPR regulations. BDR delivers end-to-end encryption of FHIR data and automates the review of data fields that might contain personal health information or personally identifiable information. BDR also encrypts all data in the FHIR blob JSON format, as it contains all the data in the FHIR RDBMS plus additional data not found in the relational database system. Violating any of these regulations and allowing PHI and or PII information to be breached could mean many millions of dollars in fines, loss of customers, and damage to your brand and company's reputation. We will be showing examples of this encryption in the videos now coming up. Now we're going to take bulk bundled data and migrate it with the help of BDR and have it ingested into the FHIR repository. And as we see here, this is not encrypted JSON format HL7 type healthcare information. And again, this will be fully encrypted once it's ingested into FHIR repository. We're going to run a BDR job to do bulk bundle loading, and this can also be executed from the graphical interface. So while this is running, we see that the new repository is empty, but we're going to refresh it. And here we can see we are now accumulating data in the FHIR repository. So as we look at the different tables, we see that there's data, and we see that there's encrypted data where there would normally be decrypted patient and other resource type data in there. So here we can see that blobs are being written also into the database, which stores all of the patient data plus what's in the encrypted data in the database. As we open up the blobs in different rows randomly under different resource types, we can see that the data inside the blob is encrypted. Even though it's compressed normally in a zip format by FHIR, we have encrypted the compressed format. So this makes it in a breach unhackable. And we're using AES 256 encryption. And again, as we see, what would normally be individualized patient PHI and PII, it is safely encrypted. And here we can see the bulk bundle job has completed. Next, I will be showing and demonstrating the FHIR API URL calls to retrieve data for viewing and usage. Now remember, the data is encrypted at rest, as it is with us in motion, and the user would normally receive unreadable encrypted data by doing a basic API URL call to the FHIR repository. BDR will use BDR microservices and migrate and FHIR interceptors to call to have the ability to display the encrypted data to the end user in a readable format. With any other query or reporting tool, or using FHIR out of the box, this protected, secured, encrypted data would not be readable to the end user or patient. So for transparency, I just want to go through showing the string data in the schema that we're going against, and we can see that the data is encrypted in the version table where the blobs are. The blobs are encrypted. So now we're going to go in with the Postman app, and first we'll look at all the patients' data and information. So as we click on this, it's just calling an API with the URL as anybody else would to look at the data within FHIR. But as we can see here, even though it's encrypted at rest, and it's still encrypted at rest, because of our calling of our microservices, we are able to see, read, and view this information and work with the information. Same as if we were to just look at a single patient's information. We can view it unencrypted due to utilizing the interceptors within Hibernate and FHIR to then be able to use our decryption and encryption capabilities, but always protecting the source data and maintaining that integrity by that data staying encrypted at all times, as I come over here and show you. That is the security in the pieces that have been overlooked by FHIR that's crucial to companies that want to meet HIPAA, CCPA, and GDPR and CMS requirements. Fire was built to deliver either one patient's information at a time or data from one of Fire's 150 or so resources in version 5. BDR developed microservices with Spark, Java, Spring Boot, Hibernate framework to allow enhanced processing of Fire data for accuracy and scalability. BDR will shortly show in a video its flexibility, opening and creating a report or query against the Fire server data. BDR may be the only application able to deliver this, as BDR has identified and mastered the internals of how Fire uses its relational database management systems data, its blob JSON data, its linkage tables, and the intricate and complex procedures to combine Fire data entries. One example of a needed query extract might be to determine how many patients have a specific disease or condition, what medications and doses they're on, the patient's gender, age, and weight, without even disclosing patients' personal information. Again, instead of just being able to process a patient at a time. Now I'm going to run a report and query, but with our data at rest, still encrypted. We're looking at the BDR demo schema. The relational database information is encrypted. The blobs are all encrypted. We're going to go into the BDR app. We're going to go into BDR demo schema. We are going to go first, just grab a couple fields from the patient resource. We'll just do address and name information. And we'll search for name. Give family name and given. We'll now go into the resource for observation. And we'll search for codes. And we'll search for subject. And at this point, we'll run the process. So that is running. That's going to create a report. Once the report has completed, we can then download that report or migrate that report, and then the report will be encrypted within the MySQL database, and we'll show how we can encrypt and decrypt that information. Now that the query or report has completed, we can view the information. There's server-side pagination to make the viewing quick as you scroll through. Now I am going to grab my iPhone and prepare it for the two-factor authentication. I'm going to select download. I am being prompted for a code 065728. I enter the code. It's then going to have me generate a key. This is an encryption key that's used for Crypto.js, SSL, SSH, our Spark job, BDR jobs, and HTTPS. I'm going to say done. I'm going to open the report. It stays encrypted, that report, until the point in which it hits my device, and now I'm able to view, save, and work with this data. Also, I can report or migrate this data to an existing database. So I have something called Steve Reports out in MySQL, and that goes into we're going to use BDR Fire, and let's take a look within BDR Fire. Well, actually, we can put it into Steve Demo and then tables. So we will come here and type in Steve Demo, and we'll create a new table called Steve New 08/29/2021. We'll test our connection and we'll run the process. So what will happen is we will refresh Steve Demo, and shortly we should see our new table. Now with the job completed and we refreshed, we should now see Steve New 08/29/2021 table was created, and it was created encrypted and securely as it should be. Now, based on one's credentials and authority, they can then come into the jobs that were run, and it is encrypted, but they can come in and say, okay, I want to decrypt that data. Are you sure? Because if they have authority, they might want to do other movement. They want to maybe do some quick queries right against it, and then they can go back in and encrypt it as they should. There is some onus and responsibility on the users that have credentials, or they'll have to work with their DBAs to get redacted copies, or get permission, or have a DBA or somebody get them the unencrypted data. We'll go check on the job now and see if the decryption process has run. So we'll refresh. And this is the file that we created. And as I said, it creates them encrypted. Let's go back and look. Migration just started. I had thought that I had submitted the job. It is now running, and shortly we will look at the results. Now that the job has completed, it says decrypted, so we will go to the MySQL Workbench. We will refresh the Steve New 08/29/2021. And there we have the decrypted table and values. Now, once again, if I'm a good user and doing what I'm supposed to do, I will click on the action once again, and migration started, and the process is running, and shortly we'll go back and refresh, and the data should be once again encrypted. Now that the job has completed, we'll go back to the MySQL Workbench, and we will refresh the Steve New 08/29/2021, and we see that the data is once again securely and safely encrypted. This is what we talk about, the capabilities of end-to-end encryption with Spark, Java, Spring Boot, Hibernate framework, which is the same framework in which FHIR revolves around. Now, from an iPhone, we are going to connect with a secured HTTPS URL to the main server for BDR, like so. And we're going to be asked for a two-party authentication. We'll enter that in there. And then we are going to, once we're in there, set up a small little report as a patient, which is required by CMS to allow patients to get billing and other information. So we're coming in through the iPhone, no extra external iPhone application, all being done securely through SSL and SSH and BDR and Spark Security. We're selecting the resources and columns that we want in our report that we want to download to our iPhone. It could be an iPad, it could be an Android, it could be any device that we want. And here we can see the job is running, and when the job is finished, we're going to view it, make sure it's what we want. We're going to request to download it, and we'll be asked again for two-factor authentication. And once that's entered, we're then going to have the file downloaded, encrypted in motion. It'll be decrypted when it hits the files within the iPhone, and then we'll be able to open up that file, look at our information, and do with it as we please, as it is the patient's information to do so. So now that the download has taken place, we're going to open up the file, and we'll put the phone sideways so we can see the data a little bit better. And there we have it. You're able to do it without an iPhone app. Lastly, we're going to show you one of the most important features of the Big Data Revealed BDR application. What you are going to see is a little query screen where we type in English, unencrypted data, and able to read encrypted data, match it, bring back the information requested. And we're going to show you what would happen if you didn't utilize this proxy. So here we can see that email is encrypted. There's Lisa, her email is encrypted. We type in Lisa to do a query, and what do we get back? An email that's encrypted. Now we turn on and allow the use of the proxy that intercepts the database communication, and when we type in Lisa, we're going to get back the actual email because our proxy converted the encrypted to decrypted. We're even going to take the email address decrypted, do the search and look up, and we can see. And we got back the decrypted email as we thought we would. The last video demonstrates BDR's proxy microservices that allow e-commerce systems, websites, applications, APIs, and other programs to receive unencrypted data from users and have it interacted with encrypted data in a FHIR or another database. This allows for business as usual for your patients, analysts, scientists, and your company. BDR's proxy microservices keeps your sensitive healthcare data encrypted at all times so that you can be HIPAA, CCPA, CPRA, GDPR, and CMS compliant, and yet use the data as if it was unencrypted. Your existing business and healthcare applications remain untouched and fully operational. What I really hope you come out with from this is in the review of key objectives and critical success factors implementing FHIR, our summary of implementing a successful FHIR server. Encryption of the FHIR server database and blob.json data is really key. Allowing patients to access and download their healthcare data as mandated by CMS. Create flexible, open, non-single patient related reports, queries, and migrations to support better business, marketing, and administrative analytics. And allow for scalable, flexible, and more accurate ingestion of data into the FHIR servers framework. I thank you for taking a long time. It's been a long video, but this is a very, very important video to the C-levels, to your patients, to your providers, to your peers, to your partners. So just practice safe keeping of your data with encryption and allow BDR to assist in that process. Thank you and stay COVID safe.